Looking at the algebraic fractions, remember the first rule with algebraic fractions is that you want to factorise first of all. You want to see if there's any common factors, anything that cancels out, anything that's going to make life easier. Don't expand until the very end, okay? And remember, you won't ever actually expand out the bottom of an algebraic fraction. So if I leave the first fraction exactly as it is, then the second fraction, I'm not going to do anything with the top at the minute. And the bottom, x squared plus x minus 6 is going to give us x plus 3 and x minus 2. So there's nothing that cancels out, but you can now see that both fractions already have an x plus 3 on the bottom. So all I need to do is multiply top and bottom of this fraction by x minus 2 to give them the same denominator. So I get x lots of x minus 2. And then plus everything on the top of that fraction, and both fractions will now be written with the same denominator, so you can in one step then write it over x plus 3x minus 2. Remember, you cannot cancel when there's only one term. This one would need the x minus 2 as well. So at this point, the only thing I can do is to now expand the top. Okay, so expanding out the top of the fraction, you get x squared minus 2x plus 6x plus 3. Over and your two brackets. That means I can then tidy the top up to give us x squared plus 4x plus 3 over x plus 3 x minus 2. At this point you want to factorise the top because we're obviously looking for that common x plus 3 factor to cancel to give us a result that looks like this. So if I factorise the top there, I get x plus 3 x plus 1, and on the bottom you've got x plus 3 x minus 2, in which case those cancel to leave us with exactly what it asked for in the question, x plus 1 x minus 2. Right, find the range of g. Well, first of all, the range is your y values, and now remember we're looking that x is greater than 3. So if you test when x is 3, you'd have 4 over 1. So I know it's got to have 4 over 1. I know it's got to have 4 in there somewhere. Okay. The other thing to test is if, obviously, we're going bigger than 3. So if I test a really big number. So if you imagine that's 10,000 plus 1 and 10,000 minus 2. So you're always dividing 10,000, or you're dividing a really big number by something that's just a little bit smaller than it. Okay. So obviously, if I divide by if I did 100 over 100, we know we're going to get 1. But if I did 101 over 98, you're not going to get 1. You're just going to get really close. Sorry, not the screen there. Okay, so it's always going to get closer and closer to 1, but you're never actually going to get 1. So that means that your function has to go between 4 and 1. And it's basically that it's greater than 1 but less than 4. Right, if we look at the second one, we want to express this function as a single fraction in its simplest form. So again, we're going to start with making any terms that need factorising factorised first. So on the top, I can factorise out an x to give me 2x plus 3 on the top of that fraction. And I can factorise the bottom of this into x minus 2, x plus 1. So before we even start thinking about making the denominators the same, I can already see that in this fraction, there's a 2x plus 3 on top and bottom. Okay, so I'm now looking at x over x minus 2 minus, and then 6 over x minus 2, x plus 1. Now I've left a bit of a gap, because to give these the same denominator, this fraction basically needs multiplying by x plus 1. So I can just put an x plus 1 on the bottom and an x plus 1 on the top. That then means they've got the same denominator, so I can just put the numerators together. If I expand this one, I get x squared plus x minus 6, and everything is over the same two fractions. Always make sure that once you've got to that stage, if it's possible to factorise the top, we are going to factorise it, because we want to see if there is anything that cancels it out to make it that little bit neater. So I could have a positive 3 and a minus 2. In which case the minus 2's are going to cancel. I get x plus 3 and x plus 1. And that's it. It's not going to go any neater than that. And our last question on algebraic fractions is this one. Again, you're always going to start off by simplifying first of all. So, by factorising first of all. So the top one, you've got 3x and x. I know that I'm trying to make minus 2, so I've got 2 and 1. I'm going to have minus 3 and add 2. On the bottom, it's the difference of 2 squares. So you're going to get x minus 1 and x plus 1. And then the other fraction is 1 over x lots of x plus 1. So you can see in this fraction, you've got an x minus 1 on top and bottom. So that's going to cancel, which leaves me with a fraction that looks like that. And then you can see, to make the denominators the same, all that needs to happen is this one needs an x. So I'm going to multiply top and bottom of this one by x. Then I've got the same denominator, so I can expand out the numerator. I get 3x squared plus 2x minus 1 over, and then x lots of x plus 1. And you always want to check that you can factorise the top, because we want to make it as simple as possible. So I've got 3x and x. That means I need a positive 3 and a minus 1. And then you've got x plus 1 times x, in which case x plus 1's cancel. We end up with 3x minus 1 over x. Okay, so remember, with fractions, you are always factorising. Okay, you won't ever be expanding other than to tidy up the top. The bottom will never be expanded.